Okay, so here again, we're going to be on 116.4 once more, worksheet 116.4. There's another set of problems here I want to hit, and that's starting with number 7. So similar kind of thing. In this case, we're only dealing with 2 loads. I mean, the process is going to be very similar. Again, I'm going to use this grid technique that I like to use. Again, ignore the other 2 columns over here. We're not going to need them, of course. And of course ignore the top part here, but for our purposes we're kind of using this little grid system here once again, and again we're going to sort of target it and tailor it to maybe pinpoint exactly what we're looking for. So in this case we have 2 elements. They're each rated differently. One is rated to deliver 4.8 kilowatts at 250 volt, the other is 5.2 kilowatts at 240 volt. So one of the first things I want to point out, be careful, they're using kilowatts here. All of our calculations deal with watts, so we're going to have to do some quick conversion. That shouldn't be an issue. I don't think. We can make pretty quick work of that. So first thing we're going to do, what's our source voltage? What's our applied voltage? What are we working with? So in this case again 472 volts. So what do we have, a 480 service? Maybe it's a little under for some reason. So maybe we're curious to see if we can actually work at this voltage here. Whatever the case, we can use these same principles to find the missing pieces. So again, we can't really go anywhere until we find what you're all sick of doing by now, is your fixed resistances, of course. Let's just get it out of the way, knock it out early. So R1 would be 4.8 kilowatts at 250 volts. So the first thing I want to mention, of course, 4.8 kilowatts, let's convert that to watts. We're going to move our decimal point 3 places to the right in this case to go from kilowatts to watts. So we're going to go 1, 2, 3. That would put us at 4,800 watts. So hopefully you guys are good with that quick calculation as it is. We should be good at that by now. So we have 4,800 watts at 250 volts. We're looking for ohms. So what are we going to do? We're getting used to this one by now. R equals E squared divided by P. So this time I'll try to use my squared function here if that makes any more sense. So we have 250 volts. Right, and we're going to say squared, and then we're going to go ahead and divide by our P value, which of course is 4,800. So that gives us, for our fixed resistance of element 1, 13.021. Okay, so we're going to do the same thing for element number 2. Again, E squared divided by P is going to do the trick. Again, remember 5.2 kilowatts is 5,200 watts. 3 places to the right to go from kilowatts to watts. So we can say, once again, E squared, so 240 squared divided by our wattage, which we said was 5,200 in this case, gives us 11.077 ohms for fixed resistance. Okay, so once again, what are we looking for here? We need the kilowatts of element 1 or the wattage of element 1. We still don't have enough to do that. We're looking for 2 values here. So again, you're gonna see a pattern here. What do we know enough to complete? Again, we know R total equals R1 plus R2. So we can simply say, of course, R1 13.021 plus R2, which is 11.077, and we get a total resistance of 24.098 ohms. Okay, so again, at this case, let's keep in mind what we're shooting for. We want to find this value here, the wattage of element 1 or the kilowatts. Still don't have enough, so just like we did in the last set of problems, the only thing we can find at this point is our amperage, which is always a great idea, because we know amperage is equal anywhere in a series circuit. So if we're looking for amperage, we have in this case watts and ohms, E and R, so we can say E divided by R equals I. Okay, so E 472 divided by R, which is 24.098, we get an amperage of 19.587. And as we know, amperage in a series circuit is equal throughout the circuit, so we can copy and paste that over into the other 2 columns. So now we're looking for our wattage or kilowatts. We do have 2 values here. We can use Ohm's law to find our wattage. So we have amps, we have ohms, so if we need power, we can say I squared times R equals P. So in this case, we can say 19.587 squared times 13.021, our R value, and we get a wattage of 4995.514. So again, theoretically, that is almost our answer. They want us to find it in kilowatts. Can we convert that to from watts to kilowatts fairly easily? We sure can. It's just the reverse of the process we did in the beginning. Instead of going 3 places to the right, we'll go 3 to the left. So if we go 1, 2, 3, we end up with 4.995, and again some change we have to round off. So 4.995 down here, right? So again, we just did a whole lot of work to find one answer, but it's going to start paying off when we have these sort of repeat problems here. So now they want to know the wattage of element 2 in kilowatts. Well, what do you know? We already have what we need up here from the last equation. So again, we have I, we have R, we need P. So in this case, we can say I squared times R once again. So we'll go 19.587 squared times 11.077, and we get 4249.697. So again, be careful, we're looking for kilowatts over here. This is watts. We can convert that 3 to the left once again. 1, 2, 3. We get 4.249, and again, if we have to round that, we will end up back to 4.250, right? So again, we didn't have a whole lot of work here to find that second problem. We've already done a lot of that ahead of time in the first problem. So now they want to know the total power delivered to the loads, or both elements, in watts. So we want to know the total power of this circuit, as the question says. So we've got some options here, because guess what? We've already got 3 values here. We could do Ohm's law, but I'm kind of sick of doing Ohm's law, so we do have another option. We know total power, P total, equals P1 plus P2 from our series circuit rules. So let's go ahead and just add those up. Either way, we should get the same answer, or you know, very close, barring any rounding discrepancies. But we're going to take P1 plus P2, which is 4249.697, gives a total of 9245.211. So I guess if I put it in the right box, it'll help, right? 9245.211. So again, we can come down here, 9245 we like for our total wattage, right? Okay, and then this one's quite honestly kind of a silly question at this point. We couldn't have done any of these others without figuring this out already. But the fixed resistance of element 2 is blank ohms. Well, again, we figured that out on step 2 or 3 here. So fixed resistance of element 2 right here, 11.07. You know, that's another reason I sort of like this grid method, because you kind of memorialize all your previous work and answers, and you know exactly what numbers belong to which values. If you had just written that out on scratch paper, you'd be trying to go back through and find the right step. You know, if you do show your work or do your notes like I do, it's kind of a mess. So this keeps it nice and orderly and useful in moving forward. So I'm a big fan of this method. You don't have to do it this way. If you get familiar with these steps, again, you can sort of pinpoint this, just jotting it down on paper or on a calculator without actually drawing this out. But I think when it comes to sort of visualizing all the steps and how they come together, this is a great way to do it. And in fact, we have sort of a nice check here once again. And let's go ahead and finish out the rest of these 2 unknown values. So if we need volts here, I want to use Ohm's law from this column to find voltage here and voltage here. Okay, so we're looking for volts. We have all the values, so let's pick an equation that's easy. E equals I times R. Let's go ahead and do that one. So E equals I times R. Right, so 19.587 times 13.021. Keep it simple here. 255.042. Okay, so in this case, we actually have some options. We could use our series circuit rule. We know E total equals E1 plus E2. So I could do some algebra. E total minus E1 equals E2. I don't really want to do that. You could. I'm going to do Ohm's law here because I'm going to show you a little check sort of at the end. So again, let's go ahead and use our same formula we did, E equals I times R. This time we're looking at load number 2. So we can say I is 19.587 times R, which is 11.077, and we get 216.965. Now that's not in the questions, I don't think. Let's go to the next page. Hope I ran out of time. So anyway, I think that's all the questions they have for you there. But the reason I showed you that is, let's actually check that. Do we trust that these are the right answers? Well, let's go back to our series circuit rule. E total equals E1 plus E2. Well, let's go ahead and add up E1 plus E2. We should get something very, very close to that, to our current total voltage. All right, so we'll say 255.042 plus 216, excuse me, 0.965. What do we get? 472.007. Again, that's negligible rounding discrepancy. So it's a nice check for you. You can sort of use these rules retroactively to check your previous work as well. Another check that I really like to look at is, you know, all these elements are rated. In this case, R1 should be 4,800 watts at 250 volts. But we're actually giving it a little bit over 250, aren't we? So guess what? The wattage actually went up a little bit as well, as we should expect. Same thing, but the reverse here for element 2. If we operated at 240 volts, we should get 5,200 watts. We're actually under our 240 volts by a good bit. So guess what? Our wattage in turn went down quite a bit as well, down to 42, 49. So again, just some sort of built-in checks you can use to check your previous work. Again, another reason I really like this table approach. Again, hopefully this helps get you guys in the right direction. As I said before, please don't hesitate to reach out if you need a little bit more help or guidance.